Okay, welcome back to the Dublin Academy of Maths. Now if you want to get me on dublinacademy@gmail.com, that's my email. Now today it's going to be I'm just going to go over a few diagrams, and here we've got a histogram. Now a histogram differs from a bargram in that there's spaces in between. Okay, they're just isolated, they're like that, okay? And okay, so that's just the difference. Now, let's be looking at this histogram here. Now, frequency on the y-axis, and down here we've got the samples. Okay. Now, I'm going to say something here. This box is bigger than these ones here, so I'm going to take the basic as 1 unit here. The frequency represents the frequency equals to the width by the height. So the frequency of this is 1 by 8 is 8. The frequency of this is 2 by 2 is 4. Okay? It's the area underneath. Okay? Frequency always related to area, even in curves. Okay? So the area of this is, there's 1 unit across, and the width is 1 by 4, there's 4. So these two are exactly the same, but they're two sample sizes are the same. They're included in this. Okay? Now they're not differentiated, it's included in this sample. Okay, so the area of the box, we call these bins, they say, the area of the bin is equal to the frequency. Okay? Now this is a probability distribution again. You see that it's gone in the same as a normal distribution. Used in quality control and population density studies. Okay? Anything else? A graphical representation of data estimates the probability distribution of a continuous variable. Okay, these are the variables, so there's some sort of probability distribution. So once you can hit something, you can calculate the probability of its frequency. Okay, so that's where probabilities come in. Used for density estimation and population habits. Okay, now remember that bar charts have spaces. Okay, now let's have a look. Can you find anything? Can you find the mean out of this? Okay, so the mean would be or the most common element here is this one. Okay, so remember this is the most common element. So that's the mode. Okay, and the mean is included in here, and so would the standard deviation. Now we'll probably include it on the left hand side, okay, because this box is bigger. Okay, so taking these two together would give you a mean over on this side. Okay, so the mean would be beside that, and then the median would also be there as well. So the mode, median are all related. This is the central tendency. Okay, mode, median, and mean. Okay, are located near this central tendency. Now, so that's really that answered. Remember that the area of the box is equal to the frequency, length by breadth. Okay, common areas. Now this is series, as you know, series 11, episode 4 on paper 2, statistics. Now this is a cumulative frequency curve. Okay, also known as an ogive. Okay, anything with a point is an ogive. Okay. Now this is cumulative. That means it's they're added. All the numbers are previously added. It's done in percentages, or you can get 75%, or if you're looking for Q1, I jumped the gun there a bit. So this is the quartile range. This is the first 25% of the frequency. So this doesn't have to be percentages, but it's, in this case it's represented as percentages, but I could change that to anything. Okay, but once I get the 25% of the sample size. Okay, Q3 is 75%. Okay, 75% of the sample size. Okay, so in other words, this is the Q3 minus Q2 is equal to the interquartile range. Okay, interquartile range. We did this before, the interquartile range on the stem and leaf. Okay, so that's the interquartile range there. That's your range. That's the time you have to wait, or whatever is the range. Now it's usually related to climate change. They usually use these graphs referring to climate change because it's a gathering of information previously. It's a frequency of phenomenons. Okay, so that's related to climate again. Now the data is in an ascending order. As I've said, it's accumulative, and the interquartile range is here. Okay, so there's the interquartile range. Okay. Have I anything else on this? Okay, nothing really there. It's an ogive cumulative frequency curve. Right, now the empirical rule. We did the empirical rule the last day. And the empirical rule is known as the 3 sigma rule. Nearly all the data pieces lie within 3 standard deviations. 3 standard deviations, okay, of the mean, right? The median of the mean, and so the plus or minus 3 standard deviations is 95%. I did this before in the curve. Do you remember? In the normal distribution curve. The normal distribution curve, we know that the points, they lie between 19, I said 97. Some graphs have different amounts, okay, but it's 97 or 95 is in the 90s, okay? That's all you need to worry about there. The median is here, the median, the mean, and the mode, most occurring, okay, will be in that this interquartile range is the range which we're interested in, which is similarly to the central tendency, okay. So remember the empirical rule, okay. Now you could be doing a few questions as you're going along here, you know, looking for diagrams in your papers. You should have your papers by now, the past papers. And you should be looking at questions and trying to figure them out and trying to interpret them yourself, okay? So remembering this, it's cumulating, it's a cumulative, and remember how to get the upper quartile, lower quartile from this. Thank you.